So today we're going to be talking about Addison's disease, and with Addison's disease you have two major types. So atypical or secondary Addison's and typical or primary Addison's. Primary Addison's is the usual one you're going to see, and that's going to be the result of an adrenal lesion. And this adrenal lesion is going to affect all three layers of your adrenal cortex. With secondary Addison's or atypical Addison's, it's only going to affect the inner two layers. And either this is going to be because of immune-mediated destruction of those two layers, or because there's a pituitary lesion. This pituitary lesion is significant because the inner two layers are under the control of ACTH, which is produced by the pituitary gland. The outermost layer is controlled by renin and iron concentrations in the blood. So, to continue here, atypical Addison's will result only in hypocortisolemia. The androgens produced by the innermost layer are negligent, so you won't have a major effect there. The hypocortisolemia is going to result in muscle weakness and lethargy. So with typical Addison's or primary Addison's, because it affects all three layers, you're going to have the hypocortisolemia causing weakness and lethargy again, and you're going to also have a lack of aldosterone in the bloodstream, which is going to result in a strange ion balance in your blood. So aldosterone is responsible for activating your sodium-potassium pump in your distal convoluted tubule of your kidney, and that's going to result in loss of potassium and retention of sodium. And water follows sodium, so if you retain sodium, you also retain water. If you have a lack of aldosterone, then you're going to have retained potassium, and you're going to lose sodium and chloride. Water is going to follow that chloride and sodium, so you're going to also have water loss along with the sodium loss. And that's going to result in hypovolemia. The potassium is going to result, the high potassium is going to result in bradycardia, and together with the hypovolemia, that's going to lead to hypotension. If you have sustained hypotension, it means that you're going to have hypoperfusion of your tissues, and that is going to lead to shock. The shock causes hypoxia, or part of the shock is you have hypoxia of your gut wall, and that's going to lead to gastric ulcers. The bleeding from the gastric ulcers is going to contribute further to the hypovolemia, and that's going to contribute further to the hypotension, which contributes even further to the shock. Now, all of these contributing factors to the shock is going to lead to an Addisonian crisis.